Here you have a circuit with two current sources, 4 at an angle 20 degree amps and 2 at an angle 0 degree, and W is 3. There's an inductor, 2 Henry inductor, and a 3 ohm resistor, 1 by 6 farad capacitor. There are two nodes, V1 and V2. Since the terminals of this current source, of the resistor and the capacitor are kind of basically the same point, you can assume all of them as V1. So these two could be considered as V1 and these two could be considered as V2. Since this is a phasor problem, let's convert each of the components. Let's represent them as phasor in their phasor form. The current sources are already in phasor form. Let's convert the inductor. So to convert an inductor into a phasor form, the equation you use is J omega L. L is omega is 3 and L is the inductance, so you would get J multiplied by 3 multiplied by 2, that's 6J, and the capacitor, 1 by 6 farad capacitor. To convert a capacitor in phasor form, you would need the equation 1 by J omega C. So J omega is 3 and C is 1 by 6, 1 divided by 6. So simplifying it, you would get 2 by J multiply and divide by J, and you would get minus 2J. And the resistor remains the same as 3 ohm. The phasor forms of each of the components. Let's convert this circuit in its phasor form. So you would have a current source 4 at an angle 20 degrees with omega as 3 and an inductor, 2 ohm inductor is 6J, a capacitor 1 by 6 farad, that's minus 2J, a 3 ohm resistor, and a current source of 2 at an angle 0 degrees. Let this be V1, let this be V2. You have to find the equations to represent V1 and V2. So to find the node, to do nodal analysis, you can write how the current flows in the circuit. That would make it easier and you would avoid mistakes. So there's 4 at an angle 20 degrees flowing into the node V1. Let the bottom part be connected to ground, and let's assume a current I1 flows from V1 to ground, and an I2 and a current I2 flows from V1 to V2. Current I3 flows from V2 to ground, and a current 2 at an angle 0 degrees flows into V2 from ground. So for V1, you have 4 at an angle 20 degrees flowing into the node V1, that's represented as positive. I1 is flowing away from the node, so it's negative. And to represent I1, it's voltage across the inductor divided by the inductance. So it's V1, and the current flow I1 flows from V1 to ground divided by the inductance is 6J, and current I2 flows away from node V1, so it's negative, and I2 flows from V1 to V2 divided by the inductance is minus 2J, and that should be equal to 0. So for V2, you have I2 flowing from V1 into V2, so it's positive. So it's positive, and I2 flows from V1 to V2 divided by minus 2J, and I3 flows from V2 to ground, so it's flowing away from V2, so it's negative, and it's flowing from V2 to ground, and the resistance is 3 ohm, and 2 at an angle 0 degrees is flowing into V2, so it's plus 2 at an angle 0 degrees, that should be equal to 0. Next, we'll have to express V1 and V2 as ratios of determinants. To do that, you have to simplify this so that you group V1 and V2 together for each of the circuits, each of the equations. So V1 would be 4 at an angle 20 degrees minus V1 by 6J divided by 6J plus V1 by 2J, removing the denominator, the negative sign in the denominator, and minus V2 by 2J. That should be equal to 0. So grouping it, you would get one by 2J minus 1 by 6J times V1 minus let's do this plus minus 1 by 2J times V2 should be equal to 0, and for V2 you can represent it as V1 minus V1 by 2J plus V2 by 2J minus V2 by 3 plus 2 at an angle 0 should be equal to 0. So it's minus 1 by 2J times V1 minus 1 by 2J times V1 plus 1 by 2J minus 1 by 3 times V2 should be equal to minus 2 at an angle 0. So you know these two equations, 1 and 2, representing one and do using determinants, you would get you would get 1 divided by 2j minus 1 by 6j and minus 1 by 2j. This would be minus 1 by 2j, 1 by 2j minus 1 by 3 times v1 v2, that would be equal to 0 and minus 2 at an angle 0 degrees. So to calculate v1, you would take you would use Cramer's rule. So the denominator would be the determinant of this matrix. So this would be 1 by 2j minus 1 by 6j minus 1 by 2j and minus 1 by 2j, 1 by 2j minus 1 by 3, and the numerator, you replace the first column with the output with the right hand side, I guess. 0 minus 2 at an angle 0 degrees minus 1 by 2j, 1 by 2j minus 1 by 3, and v2 would be the denominator would be the same, 1 by 2j minus 1 by 6j minus 1 by 2j minus 1 by 2j minus 1 by 2j minus 1 by 3, and the numerator you would replace the second column with the right hand side. That would be 1 by 2j minus 1 by 6j, and this would be minus 1 by 2j. This would be 0 minus 2 at an angle 0 degrees. Made a mistake. That's not 0, that's minus 4 at an angle 0 degrees, and so this would be minus 4 at an angle 0 degrees, at an angle 20 degrees. So this would be minus 4 at an angle 20 degrees minus 4 at an angle 20 degrees.